Imagine building a structure where the ground is invisible, the currents are relentless, and a single mistake could lead to disaster. Welcome to the world of underwater construction, where civil engineers battle the elements to create bridges, tunnels, and offshore structures. But did you know? Despite working underwater, engineers rarely get wet. Instead, they use brilliant techniques to keep water away from construction sites. In this video, we'll uncover the hidden science behind cofferdams, sheet piling, and underwater concrete pouring. Have you ever wondered how bridges stand strong against raging waves? Or how massive structures like oil rigs are constructed beneath the ocean's surface? Today, we dive deep into the groundbreaking methods engineers use to conquer these challenges. From innovative vibration hammering to the power of deep-sea foundations, we'll reveal the secrets of modern underwater engineering. So if you're curious about the wonders of civil engineering, stay tuned. Don't forget to like, share, and subscribe to explore more jaw-dropping engineering marvels. Let's begin our journey beneath the waves. A group of workers battling against the violent ocean currents, struggling to complete an underwater bridge pier. Many laborers are fighting hard against the raging sea, pushing against the relentless ocean currents to complete an underwater bridge pier. But wait, can you spot a crucial mistake made by the chief construction engineer? This mistake will lead to catastrophe. Welcome to civil engineering's most challenging battlefield, underwater construction. But did you know? Despite the name, modern engineers avoid working directly under the water as much as possible. Instead, they use ingenious techniques to keep water away from the construction site. Let's dive deep into the science behind this. Chapter 1. How do engineers keep water away? The first step in underwater construction is to remove water from the work area. But how do engineers achieve this? They build a temporary dam called a cofferdam. Think of it as creating a dry island in the middle of the water. The question now is, how do we build a cofferdam beneath the waves? Chapter 2, the foundation. Guide piles and sheet piles. The first step is to set up guide piles with the help of a pile driving hammer machine. These guide piles act as a framework for the cofferdam. Then, sheet piles, long steel sections with interlocking edges, are driven deep into the seabed. This interlocking mechanism minimizes water leakage. But did you notice something special about the pile driving hammer? It doesn't just push the sheet piles down. It uses vibration. Chapter 3, the science of vibration hammering. If you look closely, you'll see tiny but rapid vibrations. These vibrations help the sheet piles penetrate the soil efficiently without resistance. Inside the machine, two counter-rotating eccentric weights generate this movement, making it easier to embed the sheet piles deep into the bedrock. Once the structure is in place, it's time for the big moment. Pumping out the water. Chapter 4. The cofferdam is ready. Or is it? As the water level drops, something shocking happens. The entire cofferdam collapses inward. But why? Earlier, when water was present on both sides, the external forces canceled each other out. However, after removing the water, the pressure difference creates an immense inward force, causing the cofferdam walls to cave in. How do we prevent this disaster? The answer: a bracing frame structure. Chapter 5. Reinforcing the cofferdam. The bracing frame system consists of components like wales, struts, and braces. These horizontal members, known as struts, provide lateral support to prevent inward collapse. With the reinforced structure in place, let's dry out the cofferdam completely. But wait, another challenge awaits. Chapter 6. The hidden danger, water seepage. As water is removed, something fascinating happens. water particles begin to move in a U-shape underneath the cofferdam due to differential pressure. This results in water seepage, which threatens the stability of the entire structure. The solution? Continuous pumping of seepage water and laying a concrete seal course to block further leaks. Chapter 7. Concrete seal course, the ultimate solution. First, we remove the soil above the hard strata using a clamshell bucket. Then, a vibrating hammer machine helps drive steel pipes deep into the bedrock. These pipes are then reinforced with steel bars and filled with high-strength concrete. But pouring concrete underwater is tricky. Engineers use the Treme method, where a special segmented pipe allows concrete to flow smoothly without mixing with water. With the concrete seal in place, we are halfway through the project. Chapter 8, the final phase, building the bridge pier. With a solid foundation, it's time to construct the bridge pier. Engineers lay down a high-quality reinforced bar skeleton and pour superior-grade concrete to ensure the structure can withstand both water pressure and the heavy load of the bridge. But before moving forward, the pier must be allowed to cure for 14 to 28 days to achieve full strength. Finally, the temporary cofferdam is removed, carefully cut just above the concrete seal course to avoid disturbing the pier's base. And there it is, a strong and stable bridge pier ready to support the new bridge. Chapter 9. The future of underwater construction. Cofferdams are just one technique in underwater construction. Engineers also use caissons, pile foundations, and advanced deep-sea techniques to build structures beneath the ocean. In an upcoming video, we'll explore the revolutionary ken technique and pile foundations, methods that are shaping the future of underwater engineering. Underwater construction is completed safely and efficiently are described here with the following ideas of experts. How underwater construction is engineering marvels. How underwater constructions are built safely and efficiently. Engineering marvels. Imagine a team of engineers and laborers battling against the relentless ocean currents, struggling to build an underwater bridge pier. Imagine a team of engineers. But wait, can you spot a crucial mistake made by the chief engineer? This single error could lead to catastrophe. But wait, welcome to the world of underwater construction, one of the most challenging engineering tasks ever undertaken. Welcome to the world. But how do engineers build underwater while keeping the site dry and ensuring worker safety? But how do engineers... Let's dive deep into the science behind this marvel. Let's dive the challenge of underwater construction. Unlike typical land-based projects, constructing underwater is a battle against water pressure, unpredictable currents, and safety hazards. Unlike typical land-based projects, that's why modern engineers have devised methods to avoid direct contact with water whenever possible. That's why modern engineers... One of the most commonly used techniques is building a temporary cofferdam, which keeps the work site dry and safe. One of the most commonly used step-by-step construction of a cofferdam. Step by laying the foundation. Engineers start by driving guide piles deep into the ocean bed using a pile-driving hammer machine. Engineers start by these guide piles ensure the correct alignment of the cofferdam. Next, interlocking steel sheet piles are installed around the worksite, creating a barrier against water infiltration. Next, interlocking steel. A vibration hammer machine helps push the sheet piles into place, penetrating the seabed without excessive force. A vibration hammer machine pumping out water. Once the sheet piles reach the bedrock, powerful pumps extract the water from inside the cofferdam. Once the sheet pile, however, water seepage is inevitable due to differential pressure. However, engineers counter this by installing a double-layered cofferdam, with sand or gravel filling the space between the sheets to minimize leakage. Engineers counter this by installing... But what if the structure collapses inward due to pressure imbalance? But what if that's where bracing frame structures come in, providing additional lateral support and preventing failures. That's where bracing frame, the science behind stability. Even after removing water, another major challenge arises: seepage forces. Even after as water flows beneath the cofferdam, it can create an uplift force, weakening the base. As water flows, engineers use a concrete seal course technique, where clamshell buckets excavate the loose soil inside the cofferdam. Clamshell bucket, hollow steel piles penetrate the bedrock and are filled with concrete to anchor the structure. Hollow steel, a TREME pipe system ensures that concrete is poured effectively underwater without contamination. A TREME pipe system, once the concrete seal course is in place, workers can safely proceed with constructing the bridge pier, which will support the final structure. Once the concrete seal course, safety measures for engineers in underwater construction. Underwater construction poses multiple hazards, such as high water pressure, equipment failure, material instability, and worker safety risks. Underwater construction poses engineers follow strict safety protocols, including personal safety gear and training. Workers wear high-pressure diving suits when working in submerged areas. Workers wear oxygen supply systems, and emergency rescue boats are always on standby. Oxygen supplies engineers and divers undergo rigorous training in underwater welding, pressure handling, and emergency evacuations. Next, we have structural safety measures. Before construction, engineers conduct a cone penetration test to measure soil resistance and determine the ideal pile depth. Before construction, double-layered sheet piles minimize the risk of water infiltration and structural collapse. Double-layered sheet pile bracing frames and reinforcement bars strengthen the foundation against extreme pressures. Bracing frames. Now, let's discuss equipment safety. Pile driving hammers and excavation machines are regularly inspected for mechanical failures. Pile driving hammers, remote-controlled robotic arms reduce the need for divers in high-risk areas. Remote-controlled GPS and sonar technology assist engineers in positioning piles with precision. GPS and cost benefits of safety measures are significant. While safety measures may seem costly up front, they provide long-term economic benefits. While safety measures, preventing structural failures is crucial. Preventing a collapsed cofferdam could cause millions of dollars in damage, delaying the project for months. A collapsed coffer, proper soil testing and reinforcement reduce the risk of structural failure, saving repair costs. Proper soil testing, reducing worker accidents is another benefit. Reducing medical emergencies and worker injuries can lead to legal liabilities, insurance claims, and delays. Medical emergencies and investing in safety training and protective gear minimizes risks, ensuring smooth operations. Investing in safety, enhancing efficiency is also a key advantage. Using automated and robotic equipment improves precision and reduces manual labor costs. Using automated and stronger, well-planned structures require less maintenance, cutting down long-term expenses. Now let's move to the final stages, completing the bridge pier. Once the bridge pier gains enough strength, usually 14 to 28 days, engineers begin removing the cofferdam. Once the bridge pier however, they cut the sheet piles just above the concrete seal course to maintain structural integrity. The result? A strong and durable bridge pier that will withstand the test of time and the relentless power of water. The result? In our closing scene, we see a time-lapse of a completed underwater bridge with vehicles moving across it. In our closing scene, underwater construction is a remarkable blend of engineering expertise, advanced technology, and strict safety measures. Underwater construction is by implementing cofferdams, bracing systems, and concrete seal courses, engineers defy the challenges of the ocean to create infrastructure that supports modern civilization. By implementing cofferdams, we hope you enjoyed this journey into the incredible world of underwater construction. Would you like to see more groundbreaking engineering techniques in action? Let us know in the comments. If you found this video informative, don't forget to like, share, and subscribe for more fascinating engineering and more amazing content. If you found this video informative, see you in the next video.